Alright guys, welcome to another video from IB Maths Made Easy, and today we are looking at chapter 4 from the IB Mathematics Core Topics SL1, which is all about equations. Now this chapter is actually pretty straightforward and simple, and I've only included around three subsections of it because I think for the other ones, the subsections you will be taught in a different unit, and some are honestly not meant to be in SL, such as using your scientific calculator, which is taught to you by your teachers and whatever. But we will be looking at the first three, which is pretty important but also pretty simple. So this video should not be over around 7-8 minutes, I guess. So first we'll be looking at equations in the form of x squared equals k. Now I just want to say that here this form has a power, so x would always be to the power of 2, or it actually could be any power, but this means that equals k. This means that k is some number. For example, here we can say x squared equals to 7, so here k 7 equals k. In this we can actually sometimes have a coefficient outside of x squared. In this case is 5. X squared equals 100, so 100 equals k. And in the last example, 7x squared equals 240. We know the coefficient is 7, and the k in this case is 240. Now, usually what questions will ask us to do is solve for x. So let us look at some example problems. So in this case, we have 3x squared minus 1 equals 8. This question is pretty straightforward. We know that we have, so in our case, 8 equals k. We have our x squared function here, or part, and we have a minus 1 here. Well, what we can do is we want to make x squared the subject. So we can actually add 1 to both sides. So when we add 1 to both sides, 1 minus 1 is actually 0. So this actually cancels out. And when you add plus 1 here, well, that just becomes 9. Now we're left with 3x squared equals 9. And now what we can now do is we can further make the subject x squared by dividing 3 by both sides. When we divide 3 by both sides, we know any number divided by that number is 1. So this actually just becomes 1. In this case, 1x squared. We don't really need to write the 1. And in this case, we become 9 over 3, which when you do your fraction, you'll get as 3. Now you have x squared equals 3. This is very similar to what the equation above we saw. So whenever we have x squared equals 3, whenever we have any number or anything to the power of something, so actually in this case let's write 3. Whenever we want to make x the subject and we have x to the power of something, we always have to, take the square root in this case. So in this case, to make x the subject, we take the square root of 3, and then we get plus or minus 3. Now I just want to reiterate the importance of this symbol. This symbol is basically plus minus, and it's read as plus minus, but it actually becomes really important because sometimes the question says to show all roots or what all values for x. And if you just write 3 or if you just write negative 3, your points are going to be deducted because it says for all values of x. So all values means that plus as well as minus. So we write plus square root 3. Moving on to the next question. 5 minus 2x squared equals 11. Pretty simple again. Here we subtract 5 from both sides. We get this as 11 minus 5 is 6 minus 2x squared. Now we can divide minus 2 by both sides again. This becomes 1, that becomes negative 3. Look, we're left with the same thing in this question. Now, the problem is, it's defined in mathematics that you cannot have a negative square root. So, therefore, x won't have any solutions. That's why, this is the answer. There's no real solutions, as x squared cannot be negative. The last question, x plus 3 squared equals 36. Now, this may seem a bit complicated, but it's really not. You know that this entire thing equals to x squared. The x squared equals k. The x squared part in this is actually just x squared. So what you can do is, again, take the square root of 36, because we have a 2. That becomes, remember, plus or minus square root 36. And when you square root 36, you get plus or minus 6. And from there, you can either get x as 3 or negative 9. Now, moving on to power equations. Well, what are power equations? Power equations are any equation which can be written in the form as x to the power of n equals k. N can be any number. X, usually there will be a coefficient for x, and k will also be any number. For example, in this case, we have x cubed equals 5, and in this example, we have 2x to the power of 4 equals 20. Again, questions will ask you to solve for x, so let's see how we do them. X cubed equals negative 27. Now, as I said before, when you have something to do squared, you will always square root that number. In this case, we have cube. So you cube root this number, and cube root is just written like this. So you have cube root of 27. Well, in this case, negative 27. So x equals cube root of negative 27, which is just negative 3. Now, x to the power of 4 plus 15. Well, we'll do our basic algebra. We'll minus 5 from both sides. Minus 5 becomes 0. Minus 5 becomes 10. And then we have x to the power of 4 equals 10. Well, we just take the fourth root of 10, which is plus minus 4 root of 10, which I'm not going to simplify. You can actually leave it like that. Otherwise, unless it states you find the exact value, then you use your calculator. Now, a different question involving a fraction. It says x to the power of negative 5 equals negative 1 over 32. Well, here we can actually write negative 1 over 32 as negative 32 without a 1. So that actually cancels out this negative with the power. But the negative still remains on 32. So you'll be left with, you'll be left with x to the power of 5 equals negative 32. In that case, you'll be taking the fifth root of negative 32, which has an exact value of negative 2. By the way, I just forgot something. For the part A, to do questions, I recommend you do exercise 4A, pretty much all of it. And for B, I recommend you do 4B, all of it, including the ones with fractions, as it won't be as simple as x cubed equals 27. It will be very complicated. Well, later on. But for now, I really recommend you do the ones with these fractions. So moving on to the last part, we went by pretty quickly, but again, you don't really need to know the other parts. So we'll look at equations in a factored form. So an equation is written in a factored form if one side of the equation is fully factorized and the other side is a 0. For example, here we can say, if let's say AB equals 0, well, then we can actually write that. Another example is x to the power x times x plus 1 equals 0. So these are all actually written in a factored form, because let's say if you have x squared plus 2x plus 4. Well, this is the expanded version of whatever the factorized form is. And from the factorized form, what we can do is we can essentially find the roots or the zeros of the equation. This is known as the null factor law. This is very useful. You will find this in almost every topic in maths, even at a higher level, such as calculus or anything, because this null factor law really allows anyone to find a zero of an equation. But this only applies to when you have a factored form, not an expanded form, because you can't really, you can in a sense, but you can't find the zeros in this sense, but you're not really allowed to. You are allowed to, but you're really wanting to factorize it, which makes it much easier. And at the basic level, you're expected to always factorize it. It only later on when you can really tell, oh, well, the one of the x here is -4. So keep in mind that you always, right now, at this level, at this stage, it only applies to factored forms. So let's look at a question. 3x times x minus 5 equals 0. So what this null factor law states is now I can actually use this factor law and say that, well, 3x will be equal to 0, as well as this entire function equaling to 0, or that part of the equation equal to 0. 3x equals 0, and, well, that's just nothing, because, well, x cannot be a 0 over 3. And or, always remember it's or, x minus 5 equals 0. And, well, if you do simple algebra, x would be 0 or 5. Actually, I like to just go back to 3x equals 0. This actually can be simplified. You'll get x equals 0 over 3, which is just 0. That's why we actually have a 0 over here. Apologies. Next question looks at a factored form again. When you actually expand it, you'll get some sort of value. And when you factorize it, this is what you get of some equation equals 0. Again, we can use our null factor law and say that x minus 4 can equal 0 and 3x plus 7 equals 0 as well. So when you do x, so if we have x minus 4 equal 0, when you add 4 to both sides, you'll get x equals 4. That's why we have an x equals 4 here. And then we take 3x plus 7 equals 0, and we can, sorry, my bad, apologies. We can actually take 3x plus 7 equals 0. And then when you minus 7 by both sides, you'll be left with 3x equals negative 7. And when you make x the subject, you'll be left with x will be either 4 or negative 7 over 3. Now, this null factor law is pretty important. So to practice this part, I recommend you do exercise 4C. Again, just do all of it, because that kind of gives you a good foundation and a basis of what these actually want. And that actually concludes chapter 4. It was, again, pretty straightforward, and you don't really need the other parts. Maybe your teacher will teach you, and that's okay, but this is kind of basics of what you need to know for what comes on later on. Thank you.